All right, I think we'll go ahead and get started now. Hello everybody, good afternoon, and thank you for joining us for today's iMapInvasives monthly webinar, where we'll be launching our 10th annual invasive species mapping challenge. My name is Douglas Knopf. I am the invasive species project specialist for New York Natural Heritage Program. I'm also joined today by Mitchell O'Neill, who is the invasive species biologist for NYNHP. And just a few housekeeping things before we get started. Today's webinar is being recorded. After the webinar is finished, you'll be getting an email with a link to the recording, as well as any other links that we go over during the presentation. All the information will also be available on the challenge webpage that we'll be linking to, and will be available on our website after the presentation wraps up today. Everybody's microphone is muted. If anybody has any questions, you can go ahead and put them in the chat box at any time. We'll have a section at the end of the presentation where we'll go over any questions. And so today, the goal of the webinar is to go through all of the species that are going to be involved in our annual mapping challenge for this year. I'll learn how to identify these species and also learn how you can participate in the challenge and submit your observations to the iMapInvasives database. So the way that's going to go through, we'll start with an introduction of the Heritage Program and iMapInvasives. We'll go through all of our species, which we've broken up into three main sections: our aquatic species, which are water chestnut, watercress, and European frogbit; our forest pest species, elm zigzag sawfly, jumping worm, and beech leaf disease; and then our four terrestrial species of emerald cork tree, Ravenna grass, mile-a-minute, and golden oyster mushroom. After we go through all of the species, we'll do a brief overview of how you can use iMapInvasives and how you can submit your data for the challenge. And then at the end, we'll have a question section for anybody who has any questions about any of the species or submitting data. And then after questions, for anybody who is new to iMapInvasives or hasn't used any of our tools before, we'll have a very brief training on how to utilize our iMapInvasives mobile app for field data collection and submitting data for the challenge. So to start off, iMapInvasives is under the New York Natural Heritage Program, or NYNHP. And this is the organization that is tasked with being the record keeper and data collectors for all of the rare, threatened, and endangered species and ecosystem type data for New York State. And as one of the greatest threats to rare species is the establishment and spread of invasive species, New York State put the invasive species database program under NYNHP. So despite being called the iMapInvasives team a lot of the time, the IS database program is more than just IMAP. iMapInvasives is the main database software that we use for housing all the data. But on top of just having the database, we have other invasive species tools like our watercraft inspection steward program. So boat stewards at local boat launches that you might see around New York State, as well as a host of different data analyses and prioritization models that utilize data from multiple New York State agencies, like our spatial prioritization model, which shows areas in New York State that might be susceptible to invasive species establishment based on things like parcel data and rare species data. So before we get too far into it, we'll establish what exactly an invasive species is and give it a definition. So for something to be considered an invasive species, it has to hit two main criteria. It has to be non-native to the area it is being established in. So this could be something like the spotted lanternfly, which is native to Southeast Asia, but it could also be closer to home. There are species that we track in our database that are native to neighboring states like Ohio or Pennsylvania, but can act invasive in certain systems within New York State. So it has to be non-native, and then it also has to be negatively impactful and create harm to the environment, the economy, and human health. And most times, a species is doing all three of these things, either directly or indirectly. So again, the example of spotted lanternfly, environmental harm would be damaging native plants. Economic harm would be the damage it causes to agricultural crops, like the grapevines that you see in the picture there. And then human health, this can be direct, like insects that sting you or plants that burn, that have the sap that burns the skin, but can also be more indirect, such as if a species is affecting a major food source for an area and all of a sudden that food source is no longer available, this could have a direct impact on human health. So if a species hits both of these points, then it's considered an invasive species. So the iMapInvasives database is where we track all of the survey data and management data that is being taken throughout New York State. So this box in the middle, this is IMAP, is kind of representative of the database itself. These boxes on the left are the data coming into the database. So we are the official invasive species database from New York State, and it's written into the contracts for a lot of the major agencies to use iMapInvasives as the record-keeping database for all the work they're doing. So things like state parks, Department of Environmental Conservation, and the PRISMs are all utilizing IMAP to record all of their invasive species work. We also rely very heavily on community scientists. While we have a lot of different agencies going out and conducting invasive species work, we rely on our community scientists and volunteers to kind of fill in the gaps where the professionals are not able to get to. So we have full coverage of data for the entire state. And then all the data that is collected through our various field tools, all is input into the main database. And then besides just being able to view the data within the database, there's a lot of different services that it provides, kind of like data out services. So things like web maps, where you can have a live view of certain species or area on your website to show what data we have for IMAP. Email alerts, if you have a specific species or area of interest, you can be automatically alerted when new data comes in for them. Reporting tools, if you want to make automatic generated reports for things like certain areas or a species list for a certain property. And then we offer, again, several derivative analyses tools. And these include things like the invasive species tiers, which shows the relative abundance and threat for certain species within statewide or PRISM regions. And then again, multiple different prioritization tools. And I mentioned the PRISMs. If you're not familiar with the PRISMs, these are the Partnerships for Regional Invasive Species Management. We oftentimes consider these to be our on the ground, like boots on the ground in the field counterpart. So iMapInvasives is the database where this information goes, and the PRISMs are out there conducting a lot of the surveys and management for invasive species. The PRISMs are also a good resource for if you're looking to get involved in local volunteer efforts, or if you want to have up-to-date information on best management practices for controlling invasive species on your own land, the PRISMs are the best resource for this information. So there's 8 PRISM regions across the state that cover the entirety of New York State. For the most part, they just kind of follow county boundaries, with the exception of the Adirondack PRISM following the blue line, and the Catskill PRISM following the Catskill Park. If you want more information on the PRISMs, or if you want to know which PRISM you fall under at your location, you can go to nyis.info/connectwithlocalhelp, and you can input your location and be linked to your local PRISM's website. So as I mentioned in the beginning, we're launching our annual mapping challenge. This is our biggest mapping challenge of the year that we've been running now for 10 years. So this started in 2016 with the main goal of filling in the data gaps for certain species that we consider to be high priority. So this started out with just a few species and has been growing over the years. Another main goal is to use this challenge to grow our user group, to get a better coverage of community scientists surveying for invasive species across New York State. And this has been going great. IMAP Network now has tens of thousands of users across the entire state. And again, we really consider our community scientists to be a very critical resource in mapping invasive species to fill in these areas that professionals are not able to get to. And then, of course, we have an incentive. there's no point in having a challenge if you don't have some sort of a prize at the end. So over the years, we've given out a host of different prizes, things like field guides, certificates, conservationist magazine subscriptions, and various other swag to the top contributors for the challenge. So whoever submits the most data by the end of the challenge will be getting selected for prizes. And then the top PRISM regions that have the most data coming in within their PRISM boundaries will also be getting trophies. So this picture on the right are some of the trophies we've had in past years that we kind of cycle around to the different PRISMs depending on who won for each year. So why these species are important, breaking it up into those three sections that I mentioned earlier, the aquatic plants, forest pests, and terrestrial species. For the aquatic plants, a lot of these have been directly suggested to us by professional partners working with aquatic invasive species out in the field. A lot of these species are thought to be a lot more widespread than we currently have data on. So these are some of our true data gap species, and a lot of our longest running species for the challenge are these aquatic species. For forest pest species, these are more so relatively new to New York and are known to spread very rapidly throughout the state or have big jumps in where they are found. And there's still a lot of ongoing research for a lot of the forest pests as far as spread prevention methods and effective management strategies for slowing them down or treating them. So for this species, we like to closely monitor where it is and how fast it's spreading around the state. And then for our terrestrial species, a lot of these species we have very little data on for New York State, or they are very recent additions to the New York iMapInvasives jurisdictional tracking list. So we just don't have a lot of data for them, or they haven't been considered an invasive species for very long. So this early data collecting can be important for informing future decisions for professionals around the state as far as what sort of conservation or management efforts to implement, as well as distribution of outreach materials for these species. A lot of these species are also very low profile. They might be kind of prolific in your area, but you might not notice them or not know that they're invasive species. So we like to draw attention to all of these species for different reasons and to kind of fill in those data gaps around New York State and determine where they are and where they are not. And with that, I'm going to hand it over to Mitch as we hop into the aquatic species identification section. Mitch?
Perfect, thanks. Next slide. And before diving into the aquatics, I just wanted to, reiterate how great it's been to have been doing this mapping challenge for the past 10 years. And I'm about to talk about water chestnut, and water chestnut is the species that it all started with in 2016, and then we added more species as the years went on. And you can play the map. The first thing that'll show is that's the summer before the challenge, and then you can see the July records for each subsequent year popping up, and you can replay it once it finishes as I'm still talking. But yeah, the goal when we started was to fill data gaps and grow the community of iMap users, and that's still the goal. Water chestnut being the one that's been out on there the longest. We probably can't really call it underreported anymore. We've got a pretty good mapping of its distribution, but of course we don't have every water body that's in, and it continues to show up in new water bodies. So we keep it on the list. And like you'll see from one of those pictures, you'll see the masks. So this challenge, a lot has happened in the past 10 years, but this challenge has kept on going. So we really thank everyone who has participated. And one thing that map is not taking into account is the not detected data. So that's also very useful to us. So there's those blank spots on the map. Some of those are places that aren't surveyed, but some of those are simply places where water chestnut is not known yet. Yeah, next slide. And so this slide shows not just July data, but all the data from before we started the challenges and all the data after, just for water chestnut. And so these are not necessarily just records submitted by people participating in the challenge. It's also a lot of the survey data from the PRISMs and other groups. But I guess what I'm trying to say is, like, if you're people who have been involved in the challenge over the years, you're a part of this. So kind of filling in our information on water chestnut and other species in the state. So before 2016, you'll see there are a lot of blank spots on the map, and then, you know, years of collaborative mapping from various partners and also community scientists during challenges. We've been able to fill in that information, which helps guide our management decisions. So thank you, everyone. And now I'll get into the aquatic species. Go to next. And so, yeah, I'll talk about these three species: water chestnut, frogbit, and watercress. And we're going to be going through lots of species pretty quickly today, but this will be recorded, and we'll have the recording and other resources on our website later on. And also, 10 species, if they're all new to you, might be daunting. So I encourage any volunteers, feel free to kind of specialize. Like, you could focus on the aquatics if you're planning to go paddling. You could focus on the terrestrials if you're going to be walking trails. And if you don't feel comfortable with one of the species on our list, like you can't really tell how to identify it, you could always ask us for help, or, you know, you could just focus on the ones that you feel more comfortable with. Nobody has to map all 10 of these species. I expect most people would, you know, focus on a couple that interest them. But we are focusing on these 10 species, so we are going to try to go through them today. Next slide. So as a general comment about aquatic invasive plants, they're not all the same. They behave, you know, slightly differently and have different specific impacts, and are, you know, more common in certain systems and less common in others. But in general, for these three species and for many invasive aquatic plants, the concerns that we are thinking about are they're often outcompeting native species by forming dense mats and monocultures. So instead of a mixture of plants, you see just this one invasive plant. And those mats can then shade out the submerged native plants that would normally grow beneath. They can change water flow, and they can impede human activities, so boating, swimming, paddling, fishing. Next. That's an example of a water chestnut mat. And so water chestnut. So this is one of the, I'd say, most distinctive ones. Once you know water chestnut, you'll be able to see it pretty quickly. So the leaves have a unique triangle/diamond-like shape with sort of a serrated edge, tooth margin. And they form these rosettes that float on the water. And they have, maybe you could put your mouse on one of the petioles. So the sort of stems going to the leaves, they have these little bubbles, they're kind of inflated, and that's how they float up at the top. Those are air bladders. They are rooted, but their stem that goes down to the bottom can be pretty long, up to 16 feet. So they can be in shallow water and in deep water. And some of you might be familiar with their fruits. I've stepped on them before, and they're pretty painful. They have those 4 sharp points. And then if you happen to see one in flower, you'll see a white flower with 4 petals. Next slide. And I went through water chestnut very quick because that one's probably one of the easier ones. For frogbit, unlike water chestnut, this one is free floating, so its roots just kind of dangle into the water a little bit. It has these distinct leathery heart-shaped leaves. They're very circular, but they have that kind of heart indentation. The roots are not normally in substrate, normally just dangling in the water, and it does send out stolons or runners, and so that's how it creates these tangled, dense mats. Frogbit is dioecious, which means the females and male flowers are on different plants. But in New York, I believe the male version has not been confirmed. So I think it's all females that we have here in New York. And they have small white flowers when they're in bloom. And so next I'll talk about some of the lookalikes. There are some other plants with like roundish or heart-shaped leaves that float on the water. So for example, water lily, that's the picture on the top left. That has round leaves, but they have a very sharp V cut out and the leaves are much larger. And the flowers are very different if it happens to be in flower. On the top right is spatterdock, also kind of roundish heart-shaped, but it's a little bit more elongated. And both of those are attached to an extensive rhizome network. So they're not really just going to pull out of the water like a frogbit would with the roots just hanging out in the water. And yeah, like I said, they're both much bigger, but when they're young, the leaves will be smaller. So you could be confused. Water shield, bottom left, that's kind of more football shaped and there's no heart-like indent in it. And if you happen to see one, if you touch the bottom, it has a really slimy, slippery texture. And little floating heart is the last one, bottom right. So that can kind of look like frogbit. If it's in flower, you'll see that there's 5 petals. And also it's a little bit more heart-shaped, whereas frogbit is more round. If you go back one to just, can you go back one slide? Yeah, thank you. Yeah, just to put that search image in people's head, like the leaves are very much round, like a quarter or something, with that heart-shaped indent. Okay, to the next species. And the last aquatic, this one's probably one of the trickier ones to ID because there is a lookalike. So this is watercress, Nasturtium officinale. And this is the same watercress that you can eat. It's a plant native to Eurasia, and obviously we've been, having it here as food, and it has started to escape, and it's being noticed in natural areas as well. It likes shallow water, wet areas. It can do kind of shallower than where we'll see water chestnut and frogbit. Like it'll even be in drainage ditches sometimes, puddles, springs, up on not up on the banks, but on the muddy banks of a stream or a lake. And it kind of does what other aquatic invasive plants do, forms these thick, dense mats, crowds out native species, and affects the flow and function. So you can see kind of that infestation level image there. Next. And so it has alternate leaves. And so the leaves they're composed of multiple leaflets. So when I'm talking about the leaf, I'm talking about that kind of whole structure with the multiple leaflets, 3 to 9. So that one that Doug just circled, there's 5 leaflets. There's a lot of variation, and it depends on what stage the plant is at. But the terminal leaflet, the one at the end, is very bulby and bulbous and round and blobby looking. If it's in flower, it has small white flowers, similar to typical like mustard-like plants. So those white 4-petaled flowers, and those turn into slender fruit pods with many small seeds arranged in 2 rows if you happen to want to cut one open. But from the naked eye, they just look like kind of those skinny bean-like things. These stems and leaves are hairless, and these stems can root from nodes and are hollow. Next. And their watercress can look like cardamine, in particular cardamine pennsylvanica. So I have a picture of that there. You can see it kind of has similar looking leaves with the leaflets and a blobby terminal leaflet, but the leaflets are kind of thinner, more divided, and that terminal leaflet is not quite as round. It's still, more long than it is wide. And if you could do next, there's another, aquatic cressy thing you might come across, but it's rare, and the leaves are even more finely divided, which gives them almost like a carrot-like look to them. So you might see that, and if you do, NYHP would be interested in that because it's a rare species. So that's Roripa aquatica. And I think that's all I have on the aquatics, so I'll hand it over to Doug.
Great, thank you, Mitch. And again, if anybody has any questions about any of these species, you can put them into the chat box, and we'll go over the questions at the end of the presentation. Next up, we are going to hop into our 3 forest pest species. So this is going to be the beech leaf disease, jumping worms, and the elm zigzag sawfly. So starting out with beech leaf disease, this is something that first cropped up in Ohio in 2012, and has slowly been spreading eastward over the past several years. It's found to affect the various species of beech, so primarily the American beech that we have across New York State, but also things like European beech and other ornamental variants that people might have planted in landscape settings. The species, or the beech leaf disease, is not 100% understood how it works exactly. It is believed to be caused or associated with the nematode species, which is called the beech leaf disease nematode. Whenever the nematode is found within the buds of a beech tree, it's associated with BLD. Like whenever there's BLD signs and symptoms, there's a nematode, but there can be the nematode without BLD, so they think that there's some sort of a correlation there, but it's still being researched further. And then on the right here, these 3 photos show kind of the different severities of beech leaf disease. So when it first crops up, it can be these dark bands that you can see if you're looking straight up through the canopy at the bottom of beech leaves. You'll see these dark bands between the leaf venation. As it gets more severe, more of the leaf veins will start to be affected, and the leaves themselves will kind of start to look a little more shriveled. And then in areas where it is very severe or it has been there for several years, the leaves will be more deformed, kind of have more of a thick, leathery texture to them, and just seem a little more crispy. And the canopies will look a little more open despite being fully leafed out. So it's been in New York for about 10 years, and over this time it has spread very rapidly to a lot of different areas. It is a main concern because of the rate of mortality that they've seen in the field. Fully grown trees can be killed within just a few years of BLD showing up in an area, and it's also shown to kill trees faster if they're younger. This also compounds with another invasive species, beech bark disease, which is already stressing out beech trees, so they are more susceptible to succumbing to diseases. So research is still ongoing, like I had mentioned, into things like the exact cause of beech leaf disease, how it spreads, what sort of effective treatment methods there are, as well as genetic resistance surveys are starting up to look for beech trees that are unaffected in areas where BLD is common and present. So if you're going to be surveying for this species, the best way to do it, like I mentioned, is to be directly underneath a beech tree on a sunny day and looking up through the canopy, where you can photograph those dark bands on the underside of the leaves. If you're photographing at the top of the leaf, it can't be 100% confirmed if you're looking at the photos, as there are several other things that could cause beech leaves to become deformed like this. And for identifying beech trees out in the field, most of the time they will have a smooth gray bark texture. If it's an area where beech bark disease is common, it may have more of a rough bark with kind of cracks and fissures in it. but you should be able to find at least a few examples of trees that have that smooth gray texture to the bark. And for the leaves, leaves are ovate shaped and have kind of that sawtooth margin to them where every tooth is the end of one of those leaf veins. The leaves themselves are smooth. They have like a smooth waxy texture to the top and bottom. And you will rarely find these trees where it's just one alone. They are a clonal species where they send up shoots from root sprouts. So if you have one, then there's typically multiple trees in an area. Next species we're going to look at is jumping worm. So this is a more of a complex of species. So there's multiple species across the two genuses of Amenthus and Metaphyre that are all considered to be jumping worms. These likely arrived in New York sometime in the 40s from East Asia and kind of flew under the radar for a while, but over the past couple of decades have really started to expand their range and become more of a nuisance. So this photo in the lower left corner is showing how they affect the soil dynamic. So the far left is somewhere where there are no worms. So you'll have leaf litter, partially broken down leaf litter, and then the soil has fine root structure and a lot of organic matter in it. This middle photo is an area where there is earthworm presence. So less of the organic matter and leaf litter at the top and less fine roots throughout. And then the photo on the right here is an area that has been infested with jumping worms. So this section here is a core sample of what it looks like if you drill down 6 inches into the soil. And you can see that that first several inches is just worm castings. So that's when the worms are consuming the dirt and then excreting out the worm castings. And this is just the entirety of the top layer of soil with organic matter is being completely eaten through. So there is no leaf litter, there is no fine root structure, and the nutrients in the soil are severely degraded as a result. For identifying jumping worms, those worm castings are a really good telltale sign of jumping worms. They'll kind of have this like used coffee ground type texture, or it's kind of this fine kind of beating of the soil. And then if you find the worms themselves, you can identify them based on the clitellum, which is that milky white band that you'll find on them. Sort of like if you wear a watch all summer and you have a tan line, it's smooth to the worm's body, which can differentiate them from earthworms, which have their clitellum kind of strapped around the worm's body, more like a saddle. The earthworm band is also found more towards the middle of the worm, while in jumping worms, it's more towards the front. If you're going to be taking photos of this species, it's best to stretch them out flat as best you can and have something in the photo for reference for size, like a hand or a coin or a ruler, something like that. And then our third forest pest species we're going to be going over is the elm zigzag sawfly. So this is another species native to Asia that was first reported in North America in 2020, where it was found in over in Canada. The main threat with this species is the larval stage will defoliate elm trees. Elm trees, obviously, something that have already been devastated by things like Dutch elm disease, so there's a lot less out in the wild. But this species is found to affect both the native elm trees that we have in New York as well as ornamentals, though I believe they do favor the native trees. And this species also has the potential to move very large distances. The distance between the very first occurrence where it was found in New York and the second occurrence was over 150 miles. So it has very high spread potential. And if you look at the map of where we have data for it in New York, it's very sporadic, like 1 or 2 records in a lot of different areas with big spaces between them. So if you're surveying for this species, the telltale sign to look out for is the zigzag feeding pattern. They'll mostly stay between the leaf venation of the elm leaf. It'll be a little more rare to find the insect itself in its adult form. And the caterpillar itself, the larva, is very small, but you can see it here in this zoomed in photo, kind of eating its way through the leaf. So to identify elm, like I mentioned, this can be found on native and ornamental elm species. But to identify an elm tree, there's a few characteristics to look out for. The leaves themselves are similar in shape to beech leaves with a few key differences. The texture of the leaf, if you were to like run your hand over the top of the leaf, is very rough, almost like a sandpapery texture, and your hand will catch on it. The margins are doubly serrate, so again, it kind of has that sawtooth margin to it, but between the larger teeth, there are several smaller teeth, unlike beech trees. The base of the leaf at the petiole or the leaf stem is asymmetrical, so it'll be lower on one side than it is on the other, and the leaf arrangement will be alternate on the tree. The bark is also very different than beech. It'll have these very deep furrows, and the bark tends to be a little bit corky. So like a beech tree is very solid bark, where if for a elm tree, if you were to take like your fingernail and press it into the bark a little bit, it's a little more spongy and you can kind of dig your nail into it a little bit. And those are our forest pest species. I'm going to hand it back over to Mitch to go through our terrestrial species now.
Sounds good. Can you go to the next slide? Thanks. So yeah, now I'll talk about these four terrestrial species. We almost could have called it terrestrial plants, but there's one non-plant in there. Yeah, I guess I'll just get started. So next slide. So this first one is Ravenna grass, Tripidium ravenae, and this is something that's been known in parts of Pennsylvania and also in New York. It's been known in Long Island and the city area. But then in March this year, it was suddenly found in these two new locations. So this is found by some DOT staff, and I saw someone on the call, so thanks for joining today. But this was found right alongside a road. And so this is a pretty big jump far away from where we knew it was before, which hopefully this was an early detection, and we're very lucky that these DOT staff noticed this strange plant and were able to identify it and send a sample to our botanist to confirm. But it is possible that it is, it could be elsewhere, perhaps on other roadsides. So that's why we're adding into the challenge today. So as of March, it's suddenly in upstate New York, in these two separate locations, a couple of miles apart, along the road. Next slide. And so in that initial picture, so that was kind of the dead stems from last year that persisted through the winter. So it was kind of a little bit degraded, but luckily the DOT folks were still able to see it and recognize it. But now I'll show pictures of it when it's alive. So I mean, it is a perennial, but like the above ground biomass dies off and then it grows back the next year. So it's this large grass species in the Poaceae family. Originally came here as an ornamental. And so it is used as an ornamental planting. So I should mention that for this challenge, we're focusing on getting data for natural areas. So if you see it, in a garden or something, we're not necessarily advertising people to be mapping intentional plantings of species like this. So if you see it, maybe take a look at it to get familiar with it. But we're really focusing on if this is escaping into natural areas. So it's very tall, up to 10 feet tall, and the plume-like flower heads are also pretty long, upwards of 2 feet. And so this can look kind of like other large grasses from a first look. So for example, maybe Phragmites, but some differences include that the flower heads on Ravenna grass are much longer than Phragmites, so up to 2 feet long. And also Ravenna grass has kind of these very long, thin leaf blades, several feet long. And so it can spread into disturbed areas as well as intact plant communities and crowd out native species and form monocultures. Next slide. And so if you have something that seems to overall kind of visually match Ravenna grass, there are a couple details that you can look at to see if it really is Ravenna grass or maybe some other ornamental grass. So one is that bright white midrib on the leaf blade. And so this is most prominent on the basal leaves. So the leaves towards the ground, leaves higher up on the stem, there might not be as noticeable of a bright white midrib. So that picture is a close-up, but usually they're distinctive enough that you can see it on a farther away picture as well. And then on the right, another thing that might hint that it is indeed Ravenna grass is if you look at where the leaf blade meets the stem, it's very furry. So lots of white hairs, and also it's kind of red underneath the leaf blade. So those are signs of Ravenna grass. With the invasive Phragmites, you will also see, some feathery hairs at that junction, but to a much less extent, and really just at that point where the blade meets the stem. Whereas the Ravenna grass, it's kind of furrier, a couple centimeters out. And also with the invasive Phragmites, you won't see that. You at least wouldn't expect that reddish tinge. So that's Ravenna grass. There's more info on the link that is provided on the Washington State Noxious Weed Control Board. Next slide. So mile a minute. This is another one where it's pretty wide. It's widespread in the lower Hudson Valley, Long Island, but then it also kind of just pops up elsewhere in the state, and sometimes is very abundant where it pops up. And on the left, you can see, it probably just looks like a mess of plants from this on your screen right now. But yeah, Doug's tracing where the mile a minute is showing up there. Kind of looks like the lighter colored plant material in that picture. And next slide. And so this one's pretty distinctive to look at. It has very perfect triangle leaves. It has clusters of bright blue berries if it's in flower. And next, that's a zoom in. One of the distinctive features of this plant is the ochrea, or plural ochreae. It's these disc-like, leaf-like things that occur on the stem, just kind of like a disc around the stem. And also in that close-up, you might be able to see those little thorns or spines. They're kind of angled backward. So that, be careful. So don't necessarily pull these without gloves, for example. And I don't think if I mentioned the overall growth form, but this is it's a vine and it's annual. I think that's all I want to say on mile a minute. So golden oyster mushroom, this is a really interesting one. We're not really sure what its impacts are yet. For this one, we did have Dr. Prisha Kaishan present on this. She's the mycologist from New York State Museum last year. So, last month. So we have that recording. I encourage people to watch that rather than my brief cliff notes right now. But just to give you the basic idea. So this is a non-native fungus. It's a very edible fungus. So it was brought here intentionally. There are people who grow it. There are also, you can buy grow kits for it. But within the past few years, it's suddenly been found beyond where it's grown. It's been found in natural areas. It's even, especially in the Hudson Valley. And so Dr. Kashian said that, she's been looking at the fungi of the forest for many years, and it's within the past 5 years, it suddenly became the most visually abundant mushroom in the Hudson Valley. And so this is not a mushroom that will kill trees or anything. It's found on dead wood or nearly dead trees. but it may outcompete other fungi, and just the fact that it's more common than our native fungi visually is alarming. And not much is known about there's not really any management options. We're not really even sure what the negative impacts are or if there even are negative impacts. So at this point, we're kind of just trying to gather information. We just added it to the IMAP list, so we don't have any data in IMAP yet. So if you, in terms of identification, I don't know my fungi very well and they can be very tricky, but this one's pretty easy. So if you're seeing a shelfy oyster mushroom and it's bright yellow, then it's pretty much golden. It's going to be golden oyster mushroom. So if you see something that looks like this, go with golden oyster mushroom. Next slide. And then the last one, so this is number 10 for today, so thanks for sticking with us. But this is Amur cork tree, Philodendron amurense. And this is a common street tree used as an ornamental tree in New York. So again, you might find it on the street, and feel free to take a look at it and familiarize yourself with it. But for the challenge, we're focusing on escapees in natural areas. So report those. Report it if you find it in a park or something, not as a planting in a park, but as a naturalizing in a park. And so it's fast growing, shade tolerant. So those are things that make it useful as a street tree in some cases. There are separate male and female trees. Is that right, actually? Did I interpret that bullet right?
Yes, yeah, it's a dioecious species.
Thank you. Yeah. And so if it's the male tree, it'll be flowers. If it's the female tree, it will be flowers and then fruit. But the clusters of fruit and flowers are upright and they droop down with weight. So you can kind of see that in the right picture, those clusters of dark colored berries sagging down. And so this has compound leaves. So maybe Doug, if you could hover your mouse around one leaf. Yeah, so it's like that thing on the bottom. There's individual leaflets around the leaf that are, so that leaf has 1, 2, 3, 4, 5, 6, 7, 8, or 9 leaflets maybe. So that's kind of similar to what you might see for an ash or a walnut, tree of heaven, sumac. But some distinctive characters are that the leaves themselves, like the full leaves, are opposite from one another, and the leaflets have smooth margins. So ash similarly has opposite leaves, but the leaflets will have teeth. And then conversely, walnut, tree of heaven, and sumac, their leaves will be alternate instead of opposite. Next slide. And this one also known in the New York City area, but then kind of pops up elsewhere. And in some cases, it's very abundant where it pops up, even if it's far away from other infestations. Next slide. And the bark is also a key character for this species. So when it's young, it's smooth with lenticels. So on the right side, you can see it's like, a twig, smooth bark, little white spots on it. Those are lenticels. As it grows older, it becomes much more distinctive. So it's very kind of chunky, furrowy texture, similar to a hackberry. And another key feature is that the inner bark is bright yellow. And so we can't necessarily recommend going around to trees and scraping off the bark, especially if you don't have permission to do that, if it's not your land. This is just kind of a feature to keep in mind. Like if you find a tree and everything seems to match and you seem pretty sure that it could be our Amur cork tree, this is a way that you can, this is a feature that would kind of let you know. Next slide. Yeah, so that was all 10 species. And, you know, I know that's a lot of species and lots of different habitats, and I don't expect that all of the participants in the challenge are going to be surveying all those different types of areas and looking for all of these different types of species. So definitely feel free to kind of select which species you're most interested in. I'll pass it over to Doug.
Great, thank you, Mitch. I also just want to mention real quick while we're on the topic that the challenge webpage on our website does have a species profile for each species with links to additional resources on each one. So if you need more information on any of these species, you can go to that page. It'll be linked in the follow-up email, and we'll go over it a little bit here as well. But if you want more information, it will be available. The last thing we're going to go over here is talking about an overview of how you can put your data into iMap. So when you submit data to iMapInvasives, it first comes in as unconfirmed, which basically means you can see it if you log into your account, but it's not yet publicly available on the main database map. Once that data comes in as unconfirmed, email alerts get sent out to a confirming network, which consists of people like the PRISM staff, professional partners in the PRISMs and DEC and whatnot. Basically people who are professionals in invasive species. They can take a look at it, take a look at the photo and confirm it. And then once it's confirmed, it'll show up in that main public database map. And then from there, it'll get sent out via email alerts. If you have alerts set up, it'll show up in the official range map. And then the data will feed into future analyses for things like the species tiers, and professionals around the state will be able to use it for planning management strategies. So for reporting, for going out in the field and actually collecting your data and reporting to iMapInvasives, there's a few different options that are available, and you'll want to plan out how you want to do it before you go out into the field. You can report directly on the desktop or mobile browser version of iMap online, like the actual database view. And then there's also several field-based data collection tools that you can utilize if you want to collect your data right out in the field. So the simplest one to use is definitely our mobile app. We suggest this if you are just starting out with invasive species surveying. And I will do, again, a little training at the very end on how to use the mobile app. But the setup for it is very simple. You basically create your account on the browser version of iMap, create your account and activate it, download the app and log into your account. When you have Wi-Fi or cell service, then you can take your mobile app out into the field where you don't have Wi-Fi or service and collect observations. And then once you're back home and have service again, upload those records into the iMap database. So the process for this, creating an account, if you go to nyimapinvasives.org, that's our main website page. There's a login button at the top right that'll bring you to account login and creation. If you already have an account, you can log into it to access the database. If you want to create an account, it's free and easy to do using your name, an email, password, and a jurisdiction, which is the state that you're operating in, so New York. When you hit the join button, it will send an email to your chosen email account with our user agreement. And once you accept the terms of the agreement, your account will be active and you can log into your account on the same page there at the top. And then that's how you access the main iMapInvasives database. Like I mentioned before, you can input records into the database directly. This is the browser version, and there's a create record button. So if you've gone out previously into the field and taken pictures of invasive species on your phone, or you have some on your computer, you can input them into the database here. One last thing I want to mention while we're on this page is if you are going to use one of the more advanced data collection field tools like the Survey 123 form, you'll want to take note of your person ID number. You don't need this number if you're just going to be using like the mobile app, but for things like the Survey 123 form, you will need this number. So depending on which tool you're going to be using, get that data. And then for the specific mobile app and Survey 123 forms, basically our field-based data collection tools. These are both things that you can download from your Apple App Store or Google Play Store. For the iMap mobile app, you can just look up iMapInvasives and have the app itself. for the Survey 123 form. Survey 123 is its own separate app, and then we have an iMapInvasives form for that app. And I'll have training links for both of those and how to set those up that I'll send in the follow-up email. And then, like I mentioned, all the records come in as unconfirmed and have to be reviewed by an expert before they show up in the database, which means that good photos are very essential to making sure that the data can get in properly. So if you're using things like the mobile app, you get one photo to showcase the species. So it's very important to make sure that these photos are focused and close up on the species and highlighting any sort of distinct characteristics that will show for sure that it is the species that you say it is. So we don't want photos that are blurry, and we don't want really zoomed out photos that show like the entire population or an entire, 50-foot tree. It's much better to have just a single zoomed in photo of a distinct characteristic, like this tree of heaven, where you can see the leaf scar, which is an identifiable characteristic, which lets us know it's tree of heaven. So take care when you are collecting photos for these reports. And then the final take-home message, we have a lot of different species in our database, but just a few of the priority species that we're really focused on, and we want you to keep an eye out during the challenge. Going out to your local areas, surveying for these species, reporting any presence that you find with a photo, and if you're out looking for these specific species and not finding them, also submitting not detected records. So like was mentioned before, not detected records still count towards the challenge, and not detected records are very important for knowing where areas have been searched. Instead of just having no data on the map, we'll at least have something that says it wasn't found here in the past. And also a reminder that you're competing for fabulous nondescript prizes and the bragging rights for the local PRISMs for having the trophies. And then just one tip, if you're going to be using any of the field data collection tools, it's always good to submit a fake species. So in our full species list, we have one that's called a fake species for testing, starts with A, so it's right at the beginning of the list. And you can submit these records as just a test. They go into the database, nobody can see them but you. So submitting these records to make sure that your tools are operating properly and that you can the process for submitting data points. I also mentioned several times that there's a web page specifically for the challenge at nyiMapInvasives.org/challenge. So there is a banner at the top of the nyiMapInvasives.org main site that'll bring you to the challenge page. It's been updated with the species for this year. And further on into July, there will be an updated dashboard once data starts coming in. So you'll be able to see the full map of where records are coming in for a certain species, as well as the leaderboard for who has the most observations for each species. So this part isn't live yet, but it will be live towards the beginning of July. And with that, that brings us to the end of the presentation. I want to thank everybody very much for tuning in. Again, more information can be found on all of the species that we went over today on nyiMapInvasives.org/challenge. If you have any questions about anything we went over today or submitting data to the database, you can reach out to us directly, iMapInvasives@dec.ny.gov. We have a host of different resources available on our website for setting up different field data collection tools or utilizing the database. I also want to take this opportunity to shout out another program we have going on right now. If you want to survey for spotted lanternfly in your area, we have an Adopt a Grid Square program where you can choose a 1 square kilometer area to survey for a spotted lanternfly nearby where you are in New York State. I also want to mention that this is the last monthly webinar for a while. The next one is going to be in September. So for those of you who are going to be logging off now, we thank you for sticking around, and we hope you have a good field season, and we'll see you again in September at this time.